Hi everybody, this is what we call in science a bag of sugar. It's called smidge and spoon sugar. I know what a spoon is. I don't really know what a smidge is though. Anyhow, the formula of table sugar is C12H22O11. We call that the molecular formula. And back in the old days, they thought that these types of things were carbons with hydrogens and oxygens attached to them like water molecules, so they called them carbohydrates. Turns out it's more complicated than that. They're not really carbohydrates, just water's loosely bound to carbon. But if you do heat this up, you'll get a bunch of black stuff in a pan and a bunch of water that comes out. And if you weighed that stuff, the carbon and the water, you could, from the percent composition, figure out the molecular formula. So let's go talk about how to go back and forth between percent of things we weigh and the formula, which is mole ratios. Let's go talk about that. And if you can tell me what a smidge is, I'd be happy to hear from you. Salutations everybody, salutations. Mike here. Today we're going to talk about the sort of transition between going from something's percent by mass to its formula. So we've got an example here. As you saw, I was talking about sugar and how someone had to figure out that thing's formula. How do you do that? Well, you could burn the thing and collect all the products of it, or like a carbohydrate, you could decompose it and collect all of the products. But let's talk about mathematically what we're going to do here. So here's this compound, hydrazine. We're not telling you its formula yet because we're going to find out what it is. It's got the majority of its mass is nitrogen, the rest of it's hydrogen. So we can see that it's got the formula somehow NXHY. And how are we going to figure that out? So, and here's where my students struggle. They're like, how do I convert from percent to moles? I know that I need mole ratio, right? I need moles there. How many moles of nitrogen, moles of hydrogen? I can't convert to percent or from percent to that. And that is because the percent composition of something is intensive, which means it doesn't matter how much of it you have, it's got the same constant, definite composition. So it turns out it doesn't matter how much we have. We could have as much as you want. It's like a fantasy problem now. I'm going to assume I have a certain mass of it. Now, how much do you want to have? It's your fantasy. You could have however much you want to have. But you know what I'm going to do? I'm going to make it easy because I'm going to say, what if I had 100 gram sample? What would happen then? Now, percents become grams. If I had 100 grams of this, 87.40 grams would be nitrogen. 12.60 grams would be hydrogen. And so what would happen then? I could convert them to moles. Nitrogen is 14.01 grams per mole. Let me reach for the periodic table to show you that I'm not just making all this up. There it is, nitrogen. 14.01. So that would be 1 mole. Hydrogen, 1.01 grams of hydrogen is 1 mole of hydrogen. So after this step, I will now know how many moles of each I have. There's hydrogen. I like when there's, whoops, there's hydrogen. 1.01. I like when we have hydrogens, they're easy, they're 1.01, and easy to remember. So 87.40 grams divided by 14.01, that is 6.238 4 moles of nitrogen. Let's find the other one. 12.60 divided by 1.01. 12.475 hydrogen, moles of hydrogen. I'm going to go over here and I'm going to form a little naughty corner called the wrong thing. And I'm going to say that okay, there's my formula right there, right? N 6.2384 H 12.47. Okay, that's silly, right? They're always whole numbers. So what are we to do? Those aren't whole numbers, but we can find the ratio. And the way you find the ratio is you divide the bigger number by the smaller number. So let's see what happens there. If I go and I take and I divide this, I'm going to divide the moles of nitrogen by itself. And I'm going to divide the moles of hydrogen by 6.2384. And you know what's going to happen? That's going to be I can tell by looking at it, it's a 2-to-1 ratio. So what I've got going on is I'm going to go ahead and this is going to be 1. 12.475 divided by 6.2384 is going to be 1.99997. Yeah. That is a 1.99997 to 1. You know what that is? It's just the error of rounding sometimes. This is N1H2, or we leave the 1 out with formulas when we do this, and we say this is NH2. Now, let's tell you some more truths. It turns out that the actual, if you were to actually see what a molecule of hydrazine would be, it's N2H4. Now, we didn't have enough information to determine that, but we have names for these things. This is called the empirical formula. That is what is the simplest ratio. Simplest whole number ratio. This is called the molecular formula. And that is the actual composition, that is the actual contents, or the actual number of atoms. Since the molecular formula in molecule. What would we need to go from here to there? Empirical to molecular, we would need to know what the molar mass, the formula weight of a mole is. And then we would find out that the molecular formula is usually a multiple, and that can include a multiple of 1. Sometimes the molecular formula is the empirical formula and vice versa. Now, as you can see here, the actual molecular formula is a multiple of 2. But still, folks, you'd need to be given more information. If they just give you the percent of each element and say, what's the formula? The only thing you could do is you could just find the empirical, unless you're told more. Let's try another one in just a smidge, whatever that is. Oh boy, we just upped the difficulty level in this, because now not only do we have 3 elements, but they gave us a formula weight. This is something called Mandelic Acid. It's got carbon, hydrogen, and oxygen. So the whole idea is we're going to find out, C, X, H, Y, O, Z. And by the way, hydrogen in a formula we'll talk about later. You can see hydrogen anywhere from being on all the way to the left, which is where you see it with an acid. If it's combined with a metal, you see it all the way to the right. In this case, when it's carbon and oxygen, it's usually in the middle, like with glucose or with a sucrose table sugar, our example, to start this whole thing. Once again, I'm going to do the same thing. Now, I don't have to, but I'm going to assume 100 gram sample. You can always start there. Now, we're going to pay for that later because this one ends in a little bit of a tough spot, and I'll show you that later. 63.14 grams of that would be carbon. I'm just taking the percents and I'm making them masses. 31.55 grams oxygen, 5.31 grams hydrogen. Just like before, I would need to convert to the number of moles of each element. So I'm using the atomic mass of each element. I'm going to find out the moles. So carbons, once again, looking in your periodic table, 12.01 grams of carbon is 1 mole of carbon. Right there. I've already looked up oxygens are 16. No, we didn't. Last time it was a nitrogen, my bad. Grams of oxygen, 1 mole oxygen. Oxygen, 16 even. Hydrogens were in the last example. 1.01 grams of hydrogen, 1 mole oxygen. And so 63.14 divided by 12.01. 5.257 moles. 5.257 moles of carbon. Let's do the next one. 31.55 divided by 16. 1.9719 moles of oxygen. Cool. 5.31 divided by 1.01. 5.25, hey, 5.257 moles of H. Now, we need a whole number ratio. So how are we going to get it? Same way we did it last time. I'm going to divide the big number by the smaller number, and then divide the smaller number by itself. So it's kind of like you say, hey, I'm going to go to this, I'm going to transfer to this college. The girl to guy ratio is, let's make it, it's my fantasy, let's make it, 4 to 1. Does that mean that there's 4 females and 1 male? No, that means that if you took the number and, it could be 1600 divided by 400, you'd have to divide big number by small number, and you divide it small number by itself. So that divided by itself. And then I'm going to divide this number by 1.9719. 5.257 divided by 1.9719. 2.666. 2.6666 and 6. It scared me. So let's go and do 5.31 divided by, same thing. Same number, Mike. Jeez, 2.666. All right, folks, here's where starting with 100 grams is a little bit difficult because I need a whole number ratio. The wrong thing to do would be it's C 2.6666, H 2.6666, and then 001. You need a whole number, and you can't be rounding that up to 3, and you can't be rounding down to 2.5 either. So you might recognize that this is 2 2/3. Told you this would be a hard one. This is 2 and 2/3. That's what 2.666 is. This is 3/3. 2 and 2/3 is 8/3. Still 3/3. 8/3. This is an 8:3:8 ratio. So this is C8 H8O3. What would that weigh? Is that the empirical? Well, it's certainly the empirical formula, because you can't get simpler than an 8:3 ratio. That is the simplest whole number ratio, and boy, did we find out that that was hard. And you know, you start recognizing your decimals. You know, something 0.5 is really something and a half. Something 0.25 is something and a quarter. Something, you know, here 0.3333 is a third. 0.75 would be 3/4. See, then you have to find the, you know, least common multiple there. Now let's see what this would weigh. That would weigh 8 times 12.01 due to the carbons. 8 times 12.01. That would be 96.08 grams of carbon. This would be 8.08 grams of hydrogen, because they're 1.01 each. 3 oxygens would be 3 times 16.0 equals 48 grams of oxygen. All added up, 48 plus 8.08 plus 96.08, 152.16. My friends, that is not only the empirical formula, it is also the molecular formula. Does that happen? Sure. Quite a bit. That happens. Let's get some examples. CO2. That's actually what's in a molecule of CO2 is 1 carbon and 2 oxygens, but you can't get simpler ratio. That is empirical and molecular. C6H12O6. That's glucose. That must be the molecular, because you could boil that down further. CH2O is the empirical. So there's times like with mandelic acid here where you can't boil it down to a simpler ratio, and you're given the information to show you that that is what's in a mole of molecules of that compound. And so that's a little bit different sort of way of thinking about compounds. But you can see that, you know, you can assume you have any amount to start. I could have assumed, what if I had 152.16 grams? I'd have to multiply times the percentage of each to find the amount of 152.16 grams that is each element. But you know what would happen that would be beautiful? You'd land right on 8, 3, and 8. And so maybe in the next one, you might want to say, hey, if they tell me the molar mass, I want to assume I've got 1 mole of it. If they tell you that, you want to assume I got that amount right there, 152.16 grams. So you can always find the molecular formula if your sample size is not 100 grams, but 1 mole. So practice, practice, practice. So we will see you folks later, and someone comment and tell me what a smidge is. Bye. Be sweet. That's a sugar pun. Dumb. Bye.